All right, so let's keep on going now with our fractional coefficients. And another way to look at a linear equation is that a variable can be placed inside a fraction as well. Now, really, it is still just a fractional coefficient, but now it looks a little bit different because we have a variable inside the fraction. So you'll notice this little x right here, it's over 4. It looks like it's inside the fraction, same as it is over here. But really, when it's all said and done, it's not a whole lot different. We're going to solve it the same way. To solve these terms, we're going to eliminate the denominator through multiplication, the same way we did before, and then we're going to remove the numerator or the coefficient of the variable through dividing or division. Okay, so that's what we're going to be doing, and we're going to do it exactly the way that we did prior. So let's start with this one here. We have 7 is equal to x over 4. Okay, this x over 4, we have to remember there's like a little 1 in front of there. And to get rid of the denominator, we start by multiplying both sides, by 4. There we go, multiply by 4. And we're going to multiply this side by 4 as well. That's going to cancel out these two terms here. And so what our result that we get is we're going to have 4 times 7, which is 28. And we're going to have 4 times 1/4, which is actually just 1. So we're going to be left with x on top. Okay, so we're left with x on top. Now, normally we would have to now divide by whatever's in front of the x, because there's often going to be a number in front of x. But because it's a 1, dividing by 1 is not going to change anything. So we can just leave it exactly as 28. X is equal to 28. And we know that 28 divided by 4 gives us 7. The second one is, again, a little bit more difficult. You'll notice here that our numerator is negative 5x and our denominator is 8. Well, to get rid of the denominator, we, again, have to multiply by our denominator. So we're going to multiply by 8. There we go, multiply by 8, which is going to eliminate those, okay, because they're the same. If they're different, it makes it a little bit more difficult. All right, so when we do that, now we have 2 times 8, which is 16. And because we got rid of the denominator, now we're left with negative 5x on the other side. Okay, so we're left with negative 5x on the other side. To get rid of that, this is where we now need to do our dividing. So to get rid of that, we divide both sides by negative 5. And we do the same thing on this side. And that's going to cancel this out. Remember, that's why we have a negative, is to get rid of the negative there. We want x all by itself. We want it to be a positive, in fact. And so we're going to get 16 divided by negative 5. Now, if you put that into your calculator, you're going to get a decimal. In fact, it's going to be 3.2 or negative 3.2. But we can just leave this exactly the way it is. Negative 16 over 5. Now, we have a negative because there's one is positive, one's negative, and that's equal to x. Now, if you change that into a decimal, okay, negative 3.2, that works as well because it is an ending decimal. Okay, it's a nice decimal, so we could leave it as a decimal as well. But if we have repeating, just put it as, or leave it in as a fraction. Okay, that's a really great answer right there. This one is okay. This one's a really great answer. Okay, leaving it as a fraction. Now I'm going to kind of go through that again, actually, and this time a little bit more in words here. But when simplifying an equation, we're going to want to try to leave the answer as a fraction whenever possible. As I mentioned, this keeps the answer as exact as possible. And now I know you may not enjoy fractions a whole lot, not everybody does, but fractions are way more accurate than decimals, especially when we're having to round our decimals. If we don't have to round, that's okay. If we need to round, keep it as a fraction. And you can just always keep it as a fraction as well. Let's do a couple more examples that deal with that. Here what we have is we got 6 is equal to c over 2 minus 4. Well, first things first, let's get that minus 4. We want to get this term by itself. So let's get that on the other side. So we're going to add 4 to both sides. And when we do that, it's going to give us 10 on this side here. Is equal to c over 2. Okay, the fraction stays the same. All right, now we have a denominator. So we have this fraction all by itself now. We want to get rid of that denominator. So what do? Multiply by 2. And we do that to this side here as well. Remember, whatever we do to one, if we need to get rid of the denominator, we have to multiply every term by that denominator. Okay, so we got to multiply it by 2. 10 times 2 is 20. If we take c over 2 and multiply it by 2, that's just going to give us c all by itself, and it tells us that c is our final answer, or sorry, 20 is our final answer for c. So we move the constant over, multiply by the denominator, and then if there is a numerator still there, we would divide by that value there. All right, next question. Okay, next example here, we have -2 is equal to -3h over 4 plus 1. Now, I'm going to show you a bit of a different way to do this than I did earlier, but in essence, it's going to give us the same value. I'm going to start by getting rid of the plus 1, so we subtract 1 from both sides. That part's not different. That part's exactly the same as we've done in the past. It's going to give us -3 is equal to -3h over 4. There we go. Okay, now notice that this whole thing is negative. Okay, we can either multiply by a negative to start and get rid of it then, or we can divide by a negative later and get rid of it afterwards. Either one works. Okay, I'm going to actually show how I'm going to multiply by -4 here. Okay, so I'm going to pretend that the denominator is negative, so I'm going to multiply by -4 here, and I'm going to multiply by -4 here. And what that's going to do is it's actually going to create a positive value right away here. So -3 multiplied by -4 is going to give us 12. Get rid of the negatives right away. And on this side, it got rid of the negative as well, so it's going to be 3h. Okay, so 12 is equal to 3h. Now notice I got rid of the negatives by multiplying both sides by a negative. Sometimes that can be really helpful. Sometimes it can be really nice. All right, final step, we divide both sides by 3. This is going to cancel out here. And I'm just going to put it on the side. So 12 divided by 3 is 4, and 3 divided by 3 is 1, so we're left with h. So h is equal to 4. Right? We've isolated our variable to come up with our answer. Okay, isolated h came up with our answer of 4. All right, one more example. So our next example here is -7 is equal to -u over 3 minus 1. Again, we got that negative in front there. Sometimes the negative is actually in the numerator, sometimes it's by itself. You'll see both as in your assignment a little later on. All right, we're going to start by adding 4 to both sides. Okay, so we add 4 to both sides. Now that's going to cancel this out here, as we've seen in the past. And -7 plus 4 is -3. Okay, still more negatives than positives. And that's going to equal to -u over 3. Okay, -u over 3. All right, now you'll notice here again, we got a negative in front there. So we can either multiply by a +3, and then we'll do the negative later, or we can multiply by a -3. And that will then take care of the negative right away. I'm going to multiply by a -3. Now the reason I'm going to multiply by -3 is because it actually saves a step later on, because there's a 1 in front of u, so we don't have to deal with that later on. It'll actually take care of itself right in this one step. -3 multiplied by -3 is going to give us +9. And if we eliminate the negative and the 3, we're just left with u. So it tells us that u is equal to 9, not u. The letter u is equal to +9. Okay, is going to be our answer. So again, if we put +9 into here, we're going to come up with an answer of -7 is going to be our final answer. Okay, so that's how we can plug it back into our equation, and then both sides would be equal. All right, I want you to work on questions 5 and 6 on the assignment, solving these types of questions where we have a variable inside of the fraction.